Welcome back. This is the end of 4.3. We're ending it with a bang with, you guessed it, word problems. Now I know I'm hearing lots of cheering in the background. I know you're super stoked for word problems. Okay, maybe not. But if we follow this process, we're just identifying key pieces and the form becomes really recognizable with some practice. So, how are we going to do this? The first thing we have to do is we need to figure out what are the variables. So we're determining what are the unknowns for the situation. What do we know and what don't we know? What does the x variable represent? How about the y variable? What does that represent? We'll talk how do we even know what we're looking for. Then determine which form to write the linear equation in. Is it in slope-intercept form? Is it in point-slope form? Is it in standard form? Now, almost never will we be given, I'm saying almost never, will we be given point-slope form. I can't think of an example where I've ever had a word problem that I would write directly into point-slope form. But I can think of tons of examples that we can either write directly into slope-intercept or in standard form. So that's what we want to be on the lookout for. And I'll show you what to look for each form. All right, so let's get into it. Example 4, we have a word problem. It says the cost to download songs from a certain website is $1.95 per song plus a one-time admission fee of $2.50. Write a linear equation to represent the situation. Now, because of my experience, I know what form this is going to be in. And the reason I know that is because of how the information is given to me. Because the information is given to me as a one-time fee and a recurring fee, that's going to be in slope-intercept form. Now, how do I know that? Well, I know that because one of those is a recurring fee. That recurring fee is dependent upon what is recurring. So what's happening over and over and over again. In this case, we're buying songs. So for every song, it's going to cost us $9.50. That's a recurring fee. It happens multiple times. So when we see the word per in a word problem, we want to start thinking, oh, okay, there's something that's recurring. Per song, we're going to be multiplying the cost of the song times the number of songs. So that's where this MX comes into play. Then the one-time fee doesn't happen over and over again. It just happens once. So we don't need a variable with that value. We just need that value. So that's like our y-intercept, a one-time adding or subtracting some value. That's how I know that it's in this form. So the first step is to write, to figure out what does x represent and what does y represent. Well, y is going to be our total. The cost to download songs is what we're trying to figure out. That is the total amount. And because we're given values that are in terms of money, we know that y is going to be dealing with money. So y is the total cost to download songs. Now, what x represents is not money, but it's tied directly to the 95 cents. So where we see that recurring fee is where that x variable is going to be. So 95 cents per song, well, we don't know how many songs. So that's what we're going to let x represent. X is the number of songs that we've purchased that's going to help create the total cost to download those songs, which is y. So our equation, if we plug those values in, 95 cents goes with the songs, the number of songs. That has to be our slope because that goes with x. And our one-time fee of $2.50 just gets tacked on to that. So that's the equation. Y equals 95 cents per song, x, plus our one-time fee. So y equals 95 cents x plus $2.50. And that's our equation. Now, to continue, we have a second part to this equation. The second part says use this equation to determine how many songs you can purchase for $31. We're given information. We need to reason through this problem and figure out where does that need to go. This is why labeling our variables is super important. We said X is the number of songs purchased. Is that what they're telling us here? What they're telling us here is to determine how many songs we can purchase for $31. X has nothing to do with money, it has everything to do with the number of songs. So Y has to do with the total cost. They're telling us the total cost is $31. So I'm going to plug that in for Y in the equation because that's where the total goes. So $31 is equal to 95 cents per song plus the admission fee, one-time admission fee of $2.50. Now we need to solve for X to figure out how many songs we bought. So I'm going to get rid of the constant, 250. It's adding, so I'm going to use the inverse operation and subtract. That leaves me with $28.50 equals 95 cents per song. So we need to divide that $28.50 by 95 cents to figure out how much each of those songs, or how many songs we were able to purchase. So X is equal to, and then $28.50 divided by 95 cents is equal to 30 songs. And I am going to put that variable, or the units, songs, because it's not $30. We already know the total was $31. We need to know the amount of songs. So we purchased 30 songs if we spent $31. Now example 5, guess what? I forgot to cover these. So close your eyes for 5 seconds. 1, 2, 3, 4, 5. Okay, you're good. Open them. You saw nothing. All right. So the cost of a dinner combo at a local diner starts out at $10.50, and it increases by $1.50 for each premium side dish ordered. This is going to be slope-intercept again. And again, the way that I know that is I'm seeing a starting fee. It starts out at $10.50. That has nothing to do with a variable. It's not recurring. It's just one time, our y-intercept. And then it increases by $1.50 for each. Each is very similar to the word per. So each means that we are multiplying the amount of money times the premium sides that we're buying. So $1.50 times the number of sides. So let's do some labeling here. X is going to represent the variable that is recurring. So that's the number of premium sides ordered. So that would be, let me get a little organized here. $1.50 for each premium side. For each means we're multiplying $1.50 times X, the number of sides. That should give us Y, which is our total cost of the dinner, once we add and multiply all of these things together. So our total, Y, is equal to $1.50 for every song. So that's where this $1.50 times X, or sorry, $1.50 times the number of sides, I'm getting my problems mixed up, plus the starting cost of the dinner. So even if you get no premium sides, the dinner combo is going to cost you $10.50. For every additional side, you're adding another $1.50, $1.50, $1.50. So because we don't know how many, that's why we've used this variable x, because we're going to multiply $1.50 times the number of additional sides that we got. Now we need to use that equation. So use the equation to determine how much your dinner would cost if 2 premium side dishes were ordered. They're telling us the number of side dishes, which is x. So we're going to replace x with that amount. So y equals $1.50 times 2. That's the number of sides, plus $10.50. So we're paying $10.50. Then we're paying for 2 additional premium sides. So that's $3 total for the additional sides, plus our original bill of $10.50 equals $13.50 as the total bill if we do the dinner combo with 2 premium sides. Then part C says, okay, now use the equation to determine how many premium side dishes can be purchased for $18. So now they're giving us the total. So that would be y. Now we know the total, so I'm going to plug that in for y. And now I want to figure out how many premium sides can I get. So if our total is $18, we calculate our bill, $1.50 times the number of premium sides plus the starting cost of $10.50. Let's go ahead and solve for x. So I'm going to get rid of the constant term by subtracting $10.50 from both sides. So that's $7.50 is equal to $1.50. Then I'm going to divide both sides by $1.50. So x is equal to 5 premium sides. That was made possible because I knew what x and y were. So labeling x and y and saying what those variables represent made it very easy for me to see where do I need to plug in 18. Do I plug it in for x or do I plug it in for y? So your turn. Write a linear equation for the problem below. So sales tax in PA, if you didn't know this, is currently 6%. We want to write a linear equation that would help us determine the total cost, we're going to use the variable t for that, of any taxable item that has a price tag of P dollars. So if you went to the store and you bought a bag of chips for $1.50, we want to know how much is it going to cost us total for the bag of chips and the tax all together. That's what this equation is helping us to find. So using our knowledge of the situation, that's what you're trying to do. So pause the video as you complete your turn number 8. T is the total cost, P is the price tag of that item, and we want 6% sales tax to be added on to the total to give us our total amount of the item with tax. Pause that. Once you're done, go ahead and hit play and we'll go over the answers together. All right, you should be done at this point. If you're a little confused, that's okay. Let's break this down. Very first step, we know we're going to start with T as our total. We also know that we have to calculate the tax somehow. So if you didn't know, 6% as a decimal is 0. Not 6, that would be 60%, 0.06. We need to multiply that value times our cost of the item to figure out how much that item costs. So for instance, for example, if I had a $2 item, if I multiply that item times 6%, that's going to tell me the sales tax, 12 cents, that I'm going to have to pay. But that just tells me the tax. I need to know the total. So what I'm doing is I'm taking that tax and I'm going to add it to that original price. So 2 plus the 12 cents. So I'm really paying $2.12. So we want to write an equation that's generic, that we can use for any cost, for any item cost. So here's what we're going to do. Instead of the $2, we don't know what that $2 is. So we're going to let P equal the price tag. And they told us that. Price tag, the original price tag is P. So if we multiply P times 6%, that's going to tell us the tax. Now, why did I add another P? Well, because I need to add that tax with the original cost, the original price of the item. If I take the original price plus the tax on that item, combine them, that's going to give me the total cost with tax. I can combine those because both of those have the variable P. This is 0.06 P and this is 1 P. So that just adds up to 1.06 P. And this is actually something I do all the time. I would do this a lot in high school until I figured it out. I used to always get slushies after work. I'd work on the farm. And so what I would do is, well, I knew it was $1 for the slushie. So I would just take $1 and I would multiply it by 1.06. And then I was like, oh, that's just $1.06. Now that one was really easy. But then if I wanted to get a bag of chips on top of that, I would say, oh, well, the bag of chips is $1.50. So now my total bill is $2.50 times, and I would multiply by 1.06. That's going to give me the cost and the tax all together. And then that would tell me how much I'm going to have to pay. So I can get my money ready before I ever got to the register. Save me a little bit of time. All right, so the total is equal to 1.06 P. That brings us to the end of 4.3. You made it. All right. So what I would like you to do at this point is complete self-quiz number 3 on the back of the 4.3 part 2 agenda. Once you are done with that, then we want to complete the practice, any remaining practice from 4.3 part 2. Make sure